All right, so if you just did what we just did, or you did 1 through 4, you saw that long division of polynomials is pretty exciting. It's about as exciting as it can get, and nothing can get much easier than that. But wait! It actually does get easier, seriously, right here. So it's one of those things where if you understand how to divide polynomials like you just did, once you do that, you earn the right to do synthetic division. Remember, a couple weeks ago I told you this synthetic substitution stuff that we were doing, while it seemed weird, and while we could just use a calculator, is going to pay off. And here's where it pays off, because we can't punch this problem into the calculator. We cannot. But we can do synthetic substitution. What are we going to substitute in to this polynomial right here? In green, we're going to substitute in whatever makes this polynomial equal 0. So what could I plug in for p? In other words, p minus 2, I need to know the value that makes it become 0. We'll solve for p. You get positive 2, right? If you plug in positive 2 here, this becomes 0. We are substituting in, or synthetically substituting in, a positive 2. So remember our synthetic substitution, the box goes this way, our polynomial goes up here, the coefficients go up there. Remember, if you're missing a term, this is in standard form and we're not missing a term, the degree goes 3, 2, this is a degree 1, this is a degree 0, we're not missing a term. But if we were, we would have to put down a 0 for the coefficient. So I just took the 4 coefficients and wrote them down in order. Remember, to start the process, we take the leading coefficient, we drop it down. Then, as we come over, we multiply this value out in front with the bottom number and we get 2. Then we add these numbers together, we get negative 4. Now we take that negative 4 and multiply it by 2, which is negative 8. And then we add straight down and we get 1. We take this number, the result down here, and multiply it by 2, which gives us 2. And then we get a 9. All right. Maybe I screwed up. Oh, I did. I totally screwed up. Ooh, shoot. See this negative 7 here, folks? That's super important. Just as important as the fact is knowing that that's a negative 6. So then we get a negative 5. All right. So we caught that mistake. So now what? Like, how does this relate to what we just did up there with division? Well, here's the deal. This is your remainder, so that goes over this p minus 2. And then remember what came in front of the remainder. The remainder was right here. This next term is your constant, then your r term, then your r squared term, or what letter we're using here, p's. This is your remainder. This is your constant, which is a positive 1. This is your next term, which would be a p, because we're using the letter p. It's a negative 4p. And then this would be the coefficient of your next term up from there, which would be p squared. So we go back in and put the variables where appropriate with the coefficients. This answer down here, these parts are actually part of your answer. It's part of the solution to the division. And so let's try that again. So we make the box. Let's see, we're not missing any terms. So we have a 1, a 4, a 1. Let me redeem myself. Negative 1. Right there. See that? I caught the minus sign, making this one negative. So now what we're going to substitute in using synthetic substitution is not this. It's what makes this equal 0, which is a negative 2. So I'm using a negative 2 out in front. So drop down your first coefficient, multiply it by this multiplier, which is negative 2 now. And you add, you get 2. Multiply it by your multiplier, you get negative 4. Add, multiply it by your multiplier, you get 6. Add, you get 5. All right, so now this 5 is your remainder. So it goes over this polynomial. Remember how we put it over polynomial? You take that polynomial. This is your constant. Then comes, which is a negative 3, then comes your variable to the first power, which we're using p here. And that's a positive 2, right, folks? So put a plus sign in front of it. Then your next degree up from there is p squared. So it's a 1p squared. There we go. Alrighty, folks, let's steal the coefficients and put them down here. And it doesn't look like we're missing any terms. So 2, 13, 12, negative 10. That goes in the box. Give yourself a row here. Now what number is going to go out here? 5 or negative 5? It's going to be negative 5 because negative 5 makes this polynomial equal 0. Drop your multiplier down. Sorry, drop your leading coefficient down. Multiply it with your multiplier. You get negative 10. Add. Multiply that by your multiplier. You get negative 15. Add. Careful, you get negative 3. Negative 5 times negative 3 is positive 15. Add that together, you get 5. We are done with the synthetic division. However, this goes over this polynomial because that's your remainder, r plus 5. This next number is your constant. It's a negative 3. This next number is your coefficient of the r to the 1 term, which is positive. This is your coefficient of the next degree up, which is r to the 2. Bada bing, bada boom. Alrighty, let's try that again. Let's steal the coefficients here. Boy, no missing coefficients on this assignment. I feel like I'm cheating you guys. Negative 12, negative 8. Mind your negatives. What goes here is your multiplier, negative 3 or positive 3? The answer to that question is what makes this binomial equal 0? What do you plug in here to make this equal 0? 3 minus 3 is 0. So we're using a 3 as our multiplier. Drop down your leading coefficient. Multiply it with your multiplier. 1 times 3 is 3. Add it together. Now 5 times 3 is 15. Add it together. 3 times 3 is 9. Add it together. 1. That's your remainder. Put it over this binomial. 1 over x minus 3. Right? Because we always put that remainder over what we were dividing by. So if this is the remainder term, this is your constant. It's a positive 3. This is your coefficient of, we're using x's here. It's a positive 5. This is your coefficient of the next degree up, which is x to the power of 2. Wow. Which one's easier? Synthetic division. But the trick is to remember that there's a couple things. That this multiplier has to be whatever makes this binomial equal 0, which is typically the opposite of what you see right there, right? Then, once we do our synthetic substitution, we put the last value over what we were dividing by, just like we did with the long division in numbers 1 through 4. But then we work backwards. To the left of the remainder is the constant term. To the left of that is your degree 1 term. To the left of that is the coefficient of your degree 2 term. So you have to put those variables in where appropriate. That was pretty sweet.